Alright, so let's talk about the players in the game here. We started with displacement, right? We went on to velocity, and then to acceleration. Alright, so displacement was typically delta D, but it could be delta Y if we're going vertical, or delta X if we're going horizontal, because it's a change in position, right? So we have a change in position somehow, some way. Typically in meters, but it could also be feet or miles or some distance measurement. Okay. So usually delta D could be delta Y if it's vertical, delta X if it's horizontal. And that delta, by the way, is the whole change in thing, whatever comes after it. Alright, so we're speaking the language. Okay, so if we wanted to look at, hey, how quickly are you changing your displacement? Alright, how quickly are you displacing yourself? So if we looked at velocity, basically on average, saying what's your displacement over the amount of time, well, that gives us something called average velocity, and that's specifically the average velocity. So I'm not looking at how, if you're starting or stopping, speeding up or slowing down, I'm just looking at how much did you displace over how much time. Now, if your velocity is changing during that time, and then we start to look at, well, what was your original velocity or your initial velocity, the velocity at time 0, if we're thinking of it that way. Or we had VF, these little subscripts, for your final velocity, the velocity you ended up at. Now, if we ask ourselves, how quickly did your velocity change? Now we're getting to acceleration. Change in velocity over the change in time. So now acceleration was A. Displacement is in meters. Velocity is typically in meters per second. Acceleration, velocity over time, meters per second, which you'll also see written as meters per second squared. Algebraically is the same. Conceptually, I tend to like meters per second because it reminds you what it actually is. Okay, so we have the displacement, the change in position. We had velocity, how quickly are you changing position, right? Displacement over time. And we had acceleration, how quickly are you changing velocity? So far, so good. Now, in our course, we'll only be dealing with constant acceleration, or constant acceleration or average acceleration. We're not going to look at how that changes. The math gets more complicated, and it's just not worth our time right now. So right now we have two equations that's worth our while. We have velocity equals displacement over time. We have acceleration equals velocity over time. Now, I'm going to move on starting with these ideas because this gives us a few things. There's another way to calculate average velocity. And that is, if your velocity is changing, you could look at your final velocity plus your initial velocity over 2. So that's another equation we could use. And if we looked at a velocity time graph, kind of visually that makes sense. If we started, let's give another color, how about green? If we started here, and our velocity increased, right? If this was VO, this was VF, initial velocity, final velocity, the average here would be right in the middle. It spends half as much time going faster than the average and half as much time going slower than the average. Okay, so that is our average velocity. So we have two ways to calculate average velocity. Displacement over time, or literally average your starting and ending velocities, as long as that acceleration is nice and smooth. Now, this equation, which we had as the definition of acceleration down here, we can rearrange this because this is really final velocity minus initial velocity over the change in time equal to acceleration. And if I solve for final velocity, which is going to be useful to me, basically multiply the time to the other side, and I add initial velocity to both sides, I get this equation, which is going to help me when I'm looking at how fast is it going now, right? Or what's the final velocity of? Well, whatever it was going, initial velocity, plus the acceleration times the time. So that's going to tell me how fast are you going now. Last but not least, we need displacement. So before, if we wanted displacement, we have a relationship here with average velocity, and that would work. All right, so we want the displacement, we rearrange, do a little bit of algebra, we can do average velocity times that change in time. Great, that'll give us displacement. But what if I'm accelerating? Or what if I don't know the average velocity or don't know the final velocity? So in that case, we have a little bit more lengthier version. We look at that initial velocity times time plus 1/2 AT squared. Right? This is going to give us any displacement at any time for any acceleration with any initial velocity. Throwing it up, throwing it down, stopping, starting, accelerating, decelerating, doesn't matter. This will tell us where that object is as long as we have initial velocity, time, and acceleration. Okay? So, a couple highlights. Again, we have displacement, so delta D. We have velocity, which could be initial velocity, which is what it started as, final velocity, what it ended as, and average velocity, which are noted as such, and acceleration. Those are kind of the three big names of the game right here. The acceleration is always going to be constant or zero for what we're looking at. Velocity is that displacement over time. Acceleration's the change in velocity over time, specifically the change in velocity over time. And if we rearrange those equations, we get some more useful ones. Just so happens that the average velocity is also the literal algebraic average between the starting and final velocities. That can come in handy. And if we rearrange this definition of acceleration, we get an equation for how fast initial velocity plus acceleration times time gives us a final velocity. And if we expand and do a little bit of work behind the scenes to get a displacement equation, we get that initial velocity times time, which, if it's not accelerating, then that whole term goes away, and it's just d equals vt like we're used to. But if we are accelerating, this term will add on however much farther or less far it would go based on your acceleration. That's kind of a quick overview, 7.5 minutes, quick overview of what we're dealing with here. For Unit 1, linear motion. Let's do this.